in Mechanical Engineering Department, Rushiramji Gayakar Patil, College of Engineering and Technology. Now, today I am delivering presentation on resistance welding. So, nowadays we require number of thin sheets material. What does it mean that thin sheets? Thin sheets includes thin sheets like 0.3 mm to 10 mm. For this purpose, we need a welding. So, such type of need we can complete by the help of resistance welding. Nowadays, many welding machines are available like TIG welding, thermit welding, MIG welding, oxygen acetylene type of welding. But resistance welding is mean that we want to weld a thin sheet from 0.3 mm to 10 mm. So, before discussion of resistance welding, what does it mean that welding? So, welding we can also define as it is the joining process in between the two metal thin sheets with the help of pressure and heat. Sometimes we cannot use pressure and sometimes we can use filler metal and or without using filler metal. So this is the very simple and precise technical definition of welding. So considering this definition is used in number of welding techniques. So thermit welding, MIG welding, oxygen acetylene welding is all welding machines is work on this type of welding definition concepts. Today we will discuss on the topic of resistance welding. So in consideration the resistance welding, we have also used such concepts of welding. So such concepts of welding, it means that we have used heat and pressure and without using filler metal. These are the welding concepts we have used in resistance welding. So this type of resistance welding is the fusion welding process in between the two metals. These concepts with the help of fusion, where after fusion of weld metal in between the two metals with using heat and pressure, we develop some spot in between the two metals where we require weld. So this concepts is used in resistance welding. In resistance welding, various components are used in resistance welding. That is, this is the supply source where we have used AC source, and this is the primary winding, as well as where here we have used a step down transformer, and this is the secondary winding, as well as this is shown a black color is a metal of this is the electrode, and its electrode name is copper. Same copper electrode is used, and these are the two metal plates where we have to weld is required. In between the two metal surface where we require weld. That's we can also say that spot weld. This is the simple concepts of resistance welding. In resistance welding, this is the primary supply source. We can also AC power supply. In AC power supply, the power positive charge, negative charge. So that simple AC power current and voltage is passes through primary winding, and this primary winding is continuously inducted in step down transformer. Where we have used a step down transformer. What's the need of step down transformer? We have used in the resistance welding. In step down transformer, we have used resistance welding. We have used step down transformer. Reason behind is that we need a much amount of current in welding, in required welding location, and minimum voltage. So these are the main concept behind that we have used resistance welding. And as well as why we cannot use a step up transformer. By using step up transformer, we get a much amount of voltage and less amount of current. This is the need we don't require in resistance welding. That's the reason behind that we have used a resistance step down transformer. Okay, this is the step down transformer. As well as we will get much amount of current and less amount of voltage. Most of the students not understand what does it mean by current and voltage. So simple is defined way we can also say that it's the current is flow of charge and voltage is the speed of flow of charge. We can also say that voltage. So that's the reason behind that we require much amount of current and less amount of voltage. As well as we have used copper electrode. So copper electrode have very less resistance. Copper electrode have very less resistance. So very less resistance is indicate that flow of current passes easily to this copper electrode. So that where not get any resistance in copper electrode. Some type of negligible resistance where we get in copper electrode. As well as this copper electrode, we have indicate that some T symbols. So it indicate that where we have used hydraulically or pneumatically system to apply pressure over this copper electrode. To reason behind that, where we can also apply in also lower direction with the help of hydraulically or pneumatically, but this is a stable condition and copper electrodes can be movable. That's why so we can also clamp, unclamp, locating devices or any other system to this over the metal plates. Okay. So concept is behind that. When primary current flow, this step-down transformer converts current value increases and voltage value decreases. This current flows this copper electrode, and this copper electrode is where we get some resistance if if any plates having less resistance, then very less current is generated over this fixed plates. So if consider that this is this metal plate having one resistance which have very high resistance, also another plate is also having some high resistance, then such situation it is found that current flows to that metal, and this metal in between the two metals generated much amount of heat resistance. In between the two metals will generated much amount of heat resistance. So heat due to much amount of resistance, high amount of heat energy is generated in between the two metal plates. So high amount of heat energy is generated, then it means that melting is developing between the two metal plates. So metals is also melt and fusion is developing between the two metal plates. So within some seconds, hydraulically or pneumatically, pressure is applied over this electrode. So within some seconds, some spot is developed, weld spot is developed. That weld spots is the output of resistance weld. So now we find that we know that how much of heat energy is developing between the two metal surfaces. So this is the main requirement. We can also calculate with the help of formula, that is H is equal to I square R T. So H means that amount of heat energy is generated in between the two metal plates. I means that amount of current flows in between two metal plates in second. R means that resistance. What amount of resistance is generated in between the two metal plates? Heat resistance is generated in electrode and this metal plate, as well as maximum resistance is generated in between the two metal plates. As same heat is generated in between the metal plate and this copper electrode. So this is the, we can also say that in this diagram, R1, this is the R1 and R2 resistance, R3 resistance in between the two metal plates, electrode and copper. This copper electrode as well as the metal plate, this is the R5 and R4. This is the maximum resistance is generated in between the two metal plates. It shows that maximum heat generated in between the two metal plates. So this R, we can also say that R1 plus R2 plus R3 plus R4 plus R5. So H is equal to I square R T. R is the addition of all resistance, and T, it means that time in second, how much of current is passed in some second. That's why some T we also amount of current in second. Okay, so this is we can also find out with the help of such formula. Now next consideration is that what are the requirements of much amount of current each passes in in between the two metal plates. So let's consider the conditions. If we use higher thickness of metal, both metals are higher thicknesses, then due to conduction in between, due to much amount of heat energy heat is generated, so this heat is transferred easily to thick sections. That's why required heat is not generated in between the two metal plates, and required amount of heat generated is not generated, then melting is not possible. So hence this is the main reason behind that we have thickness up to 0.3 mm to 10 mm only. If above 10 mm thickness of metal is found, then weld is not developed properly in between the two metal plates. This is the main reason we have also considered that we use thin sheets to weld purpose in resistance welding. Another condition is that when this metal plate have good surface finish. Also another metal plates have good surface finish. If surface finishing is good, then it is understand that if surface finishing is good, then in such a situation resistance is very less, and if resistance is very less, it is also developed very less, and such type of situation we require much current, and all this load is goes toward the step down transformer. We require much parameters of much specifications of step down transformer. So much load is increases in step down transformer, which will be increases the cost of such type of welding. Other is that if one plate resistance is very less, it means that thickness is very high and another thickness is very low. There such situation we require current in about higher thickness metals. So current required more through copper electrode. So current density is also required more. So much amount of current must be passed to this metal plate. That's why electrode diameter, tip diameter is required also.